Okay, so we are now into the discussion of our ASA and AAS congruence postulates. So ASA is a congruence postulate and AAS is a theorem. So that's AAS congruence theorem. So what are we going to do today? So our session objectives are as follows. First, we need to define and discuss ASA and AAS, and then give additional information needed in order to prove that the triangles are congruent by ASA and AAS. Alright, so what is ASA, or that is your angle side angle? Okay, congruence postulate. So by definition, ASA, or the angle side angle congruence postulate, if the two angles and the included side of one triangle are congruent to the corresponding two angles and an included side of another triangle, then the triangles are congruent. Now take note, because it's ASA, you need to consider that your side is included between the two angles. Alright, so let's consider these two triangles. So if I'm going to get angle M, okay, let's complete the ASA. So angle M is congruent to angle T here. Okay, and then for your side, say for example, we're going to consider this. Okay, line segment MA is congruent to line segment TI. And so that should be included between the two angles. So this one, okay, angle A is congruent to angle I. Okay, so you need to consider that this side should be included between the two angles. So then, triangle MAR is congruent to triangle TIN by ASA congruence postulate. Now, you can have three combinations because of course there are three angles and then there are three sides. So for as long as you have two angles and one included side. Alright. So next, let's look at this. Which pair illustrates congruent triangles by ASA postulate? So let's look at pair number 1, okay, pair number 2, pair number 3, and pair number 4. So which of these would illustrate to us the ASA postulate? Okay, let's look at pair number 1. So this angle, okay, is paired with this. Okay, angle also, angle, and then this is the side. But look at the side. Is it included or not? Okay, so the side is not included. So therefore, pair number 1 does not illustrate the ASA. Okay, next. How about pair number 2? So this is your angle paired to this. And this angle is paired to this. And this side is also paired to this side. Now, is the side included? No. Okay, very good. So this does not illustrate the ASA. Next, how about pair number 3? So this one is our angle. This is our angle. Okay, and this is our side. Side, angle, and then our angle. So, obviously, we can see that the side is not included between the two angles. So, therefore, pair number 3 does not illustrate the ASA congruence postulate. Now, we're left with pair number 4. So, we have this angle, and this is our side, and this is our angle. Similarly, this is our angle, side, and then angle. Now, is the side included between the two angles? Okay, yes, very good. So, therefore, pair number 4 illustrate to us the ASA congruence postulate. Next. So, in this case, select the pair of triangles that are congruent using the ASA postulate. So, if we can see, we have 3 triangles per set. And then, we're going to select, okay, which 2 from among these 3 triangles are congruent by ASA. So for the first, let's say this is triangle 1, triangle 2, and triangle 3. So for this one, we have angle here, side, and angle. Okay, next. So this one is angle, angle, and this side. So obviously, the side is not included here. So this one, angle, side, and angle. So therefore, we have our triangle 1 and triangle 3. So you can just name the two triangles. Alright, so that's triangle PRQ and then triangle VWX. Okay, so for letter B, let's see, this is 1, this is triangle 2, and this is triangle 3. Okay, so which pairs? Okay, would try to illustrate the ASA postulate. So this one is angle, this is side, this is angle. Okay, next, this is, we have angle, we have side, and angle, and we have side again there. Okay, but that's okay. So let's see here. This one is side, this one is angle, and this is side. So obviously, it's 1 and 2. Okay, triangle 1 and 2. Next, letter C. So this is angle, this is side, and this is angle. This one is an angle, side, and angle. Angle, side, and angle. But, okay, 1, 2, 3. So therefore, triangles 1 and 2. Okay, illustrate to us the angle, side, angle. Okay, next. So we have here a figure. Then we are asked, can this figure illustrate the ASA congruence postulate? Now, this indicate to us that this line is parallel. So we already have an angle here that is congruent to this angle. Okay, now, can you see a side that is congruent? Alright, so we can get this side, correct? Because, so, reflexive property, so we have side or line segment RQ is congruent to line segment QR, okay, whichever way. Okay, by reflexive property, so that will be RQ and RQ. Okay, and then, since we already have the side here, we can say that this is parallel. So this acts as a transversal. So therefore, we can say that this angle is congruent also to this angle. So that's A. ASA. So is the side already included? Yes. So therefore, this figure illustrate the ASA congruence postulate. Okay, next. So, we're done with the ASA. Now, let's talk about the AAS or the angle side congruence theorem. Alright. Now, what is AAS or the angle side congruence theorem? Now, if two angles and a non-included side of one triangle are congruent to the corresponding two angles and a non-included side of another triangle, then the triangles are congruent. Now, take note that AAS, the position of your side should not be included between the two angles. So, if you're going to look at this illustration, we have this triangle, okay, is congruent to this triangle. So, we have, this is your angle, okay, angle B. So, following the AAS, so let's begin with angle B is congruent to angle Q. Alright, another angle we can see 80 degrees, so that's angle C is congruent to angle R. Alright, now we're going to look at the side. Okay, the side must not be included. So we're going to get our side, that's line segment AC, congruent to line segment PR. So this side. Alright, so that's not included. Okay, so considering that these two triangles are congruent already, so meaning to say we can also get another side that is not included. So aside from this side, okay, line segment AC is congruent to line segment PR, we can also get line segment AB, okay, that's congruent to line segment PQ. Okay, since this side is still not included between the two angles. Okay, so that's very easy to memorize, right? Okay, so ASA, you have your side that is included between the two angles. That's why your S is in between here versus your AAS. So these are your two angles. So your side is not included between the two angles. So that's why the position of S here is away from the two angles. Alright. So if there is an AAS congruence theorem, can SSA and AAA be true for triangle congruence? Or can we say that we can use either SSA or AAA for triangle congruence? Okay, what do you think? So let's look at this. So this one illustrate to us the SSA. So your side, you have also your side and then your angle here. Similarly, you have your side, you have your angle, and you have your side. Okay, now, considering the two triangles, look at them. Okay, so if you can see, this is 40 degrees, which is congruent to 40 degrees here. But, obviously, yes, the two sides, okay, corresponding sides are congruent, okay, but we can see that the triangles, okay, are of different shapes. Okay, they are of different, they are both triangles, but they are not scaled according to whether or not they look the same. Okay, so you can have these two measurements that are the same with this, but this one is kind of slant. Okay, it's slant, and then it is different from the look of this one. Okay, so meaning to say, this can tell us that it's not possible to use SSA. Okay, again, let's have AAA. So considering these two triangles, we can produce two triangles even with the same angle measurements. But, okay, we can extend more the lines, okay, the sides, okay, with the same angle. Okay, so this has the same angles with this one, but okay, we can say that the two triangles are not congruent because this one becomes bigger by extending the sides, okay, compared to this one. All right, so that's why we cannot really use the AAA or the angle to prove triangle congruence. Okay, now let's proceed. Additional information needed to prove that the triangles are congruent by either ASA or AAS. So let's begin with this one. What additional information do you need to prove that the triangles are congruent by the ASA postulate? Now, let's look at this. So you already have your angle here. You already have the side. Okay, similarly, you have here your side and here your angle. So what is the remaining additional information needed for us to complete the ASA? So you need to consider that the side should be included between the two angles. Okay, so if we are going to draw the angle mark, so this angle will be considered and also this angle. So therefore, our additional information would be angle G is congruent to angle A. Alright? So, one needed information. Next. Okay. What additional information do you need to prove that the triangles are congruent by the ASA postulate? So, we have two triangles. Again, so illustrating ASA, we can say that, we already have a side that we think are congruent to each other by reflexive property. So, therefore, this side, so you have side or line segment PR is congruent to line segment PR by reflexive property. Okay, so now for this side to become included, of course, you're going to get these two angles that will become congruent. So that's angle P is congruent to angle P. Okay, so we're done. We already have the ASA. But the number of needed information or additional information here are 2. So compared to the previous one, which is we only need 1. So this one we need 2 to complete the ASA postulate. Alright, so next. Okay, what additional information do you need to prove that the triangles are congruent by the AAS postulate? Alright, so AAS. Now, let's look at this. We already have an angle here. Okay, so meaning to say that angle is congruent to this angle. Okay, and we also have the side here. Okay, now, can you see an angle that we can say congruent and that will complete the AAS postulate? All right, now, think about your side that is not included. Okay, so you need to get the angle that will make the last or the side not included. So, this is our angle. Okay, so that's angle E is congruent to angle E. So what is the reason? Because this one illustrate to us that they are vertical angles. Okay, and vertical angles are congruent. So it's now complete. AAS. Okay? So, are we going to get angle H and angle F? Of course, we are not going to get angle H and angle F because we don't have a reason to say that these two angles are indeed congruent. So, we are safe to get our angle E and angle E because they are congruent because they are vertical angles. All right. So, next. What additional information do you need to prove that the triangles are congruent by the AAS postulate? So in this case, we already have angles, right? So we have the first here. So this one is already our angle, right angle. So of course, this is congruent to this one because all right angles are congruent. And also this one and this one. Okay, so angle. Now, we are going to get the side. Okay, that is not included. Okay, so which is that side that is not included? Okay, so if you can see, that's reflexive property, either reflexive or symmetric property. Okay, so here we have the same side. So we have side TR or line segment TR, okay, and so the corresponding side would be line segment RT. Okay? So, illustrating symmetric property. But if you're going to illustrate that using reflexive property, so line segment TR is congruent to line segment TR. But let's just write it this way, okay? Considering the positions of the two triangles. Okay? So, good. So, that ends our discussion with the ASA and AAS congruence postulate and theorem.